given a root of binary tree. What we have given? We have given root of binary tree, and the zigzag path for binary tree is 3 points we have given, 4 points we have given actually. The first, it is saying choose any node in the binary tree and direct, or you can say take a left or right, and if the current direction is right, move to the right child of the current node, otherwise move to the left child, right? So if we have the current direction is right, then we have to move to the right child of the current node, right? Otherwise move to the left child. So now what we have, next we have change the direction, right? We have to change the direction from left to right, from left to right, right? Either this or this, either you go right to left or left to right. Now we have to repeat the second and third step until you can't move in the free, right? The zigzag length is defined as the number of node visited minus 1, right? And a single node has a length of 0. Return the longest zigzag path in that tree. Zigzag means what? Like this. This is called zigzag, right? As you can see, we are going left, we are going to up down like this, right? So this can be also a zigzag like this. If you're writing like this is also zigzag. So direction from the your current direction, if you're going left right like this is called zigzag, right? Now let's understand in the example. So this is the first example we have given, right? So in this example we are at current position is at here, right? So from here what will happen, or you can take the node position here, right? As you can see, so here from here you have taken what? Right, then you got a node, from there you get taken left, after right, first we have taken right, then we are taking left, and after this we have to take right like this. So you got a new node here, after that we have to take what? Right, we got a new node, right? So if we are going to continue next here, right, move, we cannot go because we have to go now what? Left, and they if we'll go this line, we don't have the node, right? And so we cannot move. So this will become, you can say, the longest for this zigzag path, right? Okay, and that's why we have given the roots we have given, and we have to return the longest zigzag path in the tree. You have move alternatively right, then left, and then right. Okay, so make sure that you will follow this rule, right? And if you get the path right, as you can see, 1 2 and 3, right, we are getting, so we are returning output 3. Let's understand here, right? We are current position at the root node, right? So from here we are going to left, then right, and then left, and then right. Means 4 move we have, and we are returning that move here. Okay, I think you got me, you understood this one, right? So let's understand here. So if there is only one node, right, so we are not taking node, we are not moving left or right, so we will say this is a self node we have, right? We are not taking extra path, we are not taking, right? And that's why we return 0. So coming back to the constant, right? So the number of nodes in the tree is a range between 1 and 5 into 10 to the power 4, right? We have, so in this case what will happen, node dot value should be greater than or equal to 1, and it should be less than or equal to 100. Okay, now understand depth first search approach, right? And in this approach what we have to do actually, first of all we have given the root node, right? Root node of a binary tree, as you can see. So our task is to find the longest zigzag path that is contained in this tree, right? So what is depth first search, right? So as you can see, right, there are only two options available from the each parent, right? We either go to its left or right child, right, if they exist, right? So what we have to observe here, so some situation in which we move from parent to its children, so we have to consider a parent node. Okay, so let's suppose we have a parent node, we can say P. Okay, now which is itself is a child, right? It's itself is a left child. So if P has a left child, let's suppose there is a parent, this is a P, right? And if has a left child, right, and that is, we can say, we can take one. So if this is the case, we have this parent node and we have one as a left children, so we cannot combine the is going into P and 1, right, because they have the same direction and do not form zigzag path, correct? Now we can only begin a new zigzag path of the length 1 by including edge P and 1, right? So if this is, you can say P, if this is a P and this is 1, right? So this path from here to here, we will consider, right? So we cannot combine the edge going into P and 1, right, because they have the same direction and do not form a zigzag path, right, because same path we have, and that's why we are considering that one. Okay, now we can only begin a new zigzag path of length 1 by including the edge P and 1. So if P has a right child and we cannot include is going into P and R, right, as you can see, we are not considering this one, right? Let's suppose this is P and this is R. Okay, so we will not consider this as a different, this one we will consider whole as a one. Okay, because both have the direction 1, same, right? So if P has a right child, as you have told R, we can include the edge going into P and R together because their direction are opposite and form a zigzag path. So if we know the length of the zigzag path until node P, including R increases the length of path by 1, you can say. Okay, so in this case we'll consider these things. Okay, now we have to assume that P itself is a right child. If it has a left child 1, we can combine the edge going into P and 1, right? The length of the zigzag path until 1 is equal to the length of zigzag path until P plus 1. If P has right child, R must start over the, you can say, edge between P and R, forming the zigzag by length 1, right? So as you can see here, right, if we have this one, right, we'll consider going this way, right? From here we can see that we have left and right children we have. So if we will consider going from here to here directly, right, as you can see, right, so this is again it's left one, right, left one, this is also left, this is also left, right, both time. So we will not start from here in this case. Okay, as you can see here, why will start from here, right, because both are same, this is left and this is left, right? So this is not good. Okay, so from here, from P, we will not start from here, we'll start from this point, as you can see, and we'll take left this one, and from here you can move to any other direction, right? So again you see here 3 it is coming, so this is also left, right? Now, so this is the way 1, right, that is not satisfied, right? Now we'll coming back to here, from here to here will come, that is left, and then we will come what, right. Similarly, if we'll directly come from P to 1, we can consider, in that case we will not go this way, we have to come this way, right? First left then we have to take what? Right. Similarly, if we'll talk about this is the P, from P we are going to 1. So first what we are taking, these both are at the same location, right? So we have to take now what? We have to take, if this is the direction we have, right? So either we'll take this one or this one. So this is not good. So we will take this one, okay? So this way we can use a graph traversal like depth first search to traverse in the tree. So in the DFS we will use recursive function to explore the node as far as possible along each branch, right? So upon reaching to the end of the branch, we backtrack to the previous node and will continue the next branch, right? So we'll see that, okay? So to stop the longest zigzag path found thus far, we define we will define an answer variable that is called path length, and we'll try to implement this one, okay? So let's understand here the code part. So first of all, we have taken what? This is the you can say answer part, okay? Answer longest answer path, right? So to store the longest zigzag path, you can say that found till now, right? We defined answer variable, and that is known as path length, and we will initialize from 0, as you can see. So we will implement a DFS method, right, that accept tree node, right, boolean go left, right, and that will indicate we should go left for the continuation of zigzag path, and one step we will take which will store the length of the zigzag path so far, right? So as you can see, we have a DFS, and it will take node, then it will take go left and its step, right? So first we'll check it should not be null, and we'll return here. So this is your base case, right, as you can see, and then we'll find your maximum between the path and step, and which one will come will update our, you can say, path will get updated, okay? So when our path is updated, right, you will get the maximum path, maximum length, you can say. So if we are going to what? Go left, right? If we are going to go left, right, as we have given, if it is true, a node dot left, then we will take, now we will not take false, right? Now we will take false, right, because next time we will not go, right? And then a step plus 1, and then we can take what? Right. We can say node dot right, and this time go left is true. Previously we are sending false, but this time we will pass true, okay? Make sure like if we already know that we are at current position, okay? So from the current position, if this is, we are going to this way, right, means this is true, right? This is true, right? So from the P to we are coming to 1, right? Let's suppose if this is what? P, okay, and this is your node 1, okay? So from root node P to here, if you are coming, so we are taking, already taken what? Left we have already taken, and that's why we are coming into here, okay? So next time we have two options, right? Either we will go this one or this one, but we have gone already left, we have gone through, right? So we will not consider this left one, right? We'll go to right one, right? And right is true, and that's why first we will take false, right, and then we will take true, because we have already started L. That's why we have came into what? This if condition, right? And if this is true, it means we will come into this one, okay? So there is two options, either we'll go this one, either we'll go this one. So if we are taking this one, means we have already taken left, so we'll mark this as a false. We are not going this one, we are going this one, okay? So for else condition, if we have not taken this initially, if we have not taken left, we have taken right, okay? So in that case, what will happen? We'll come to here this line and these options we have, right? If this is the case, means we will come into this one. So if we are coming here, let's suppose this is node 2. So node 2 has two chances, here or here. So we have already taken what? Right. So we'll not go to the right, we'll go to the left, right? And we'll consider this one, and that's why first we'll pass false and then we'll pass what? True, because we will take first we'll say false and that will take true, and will increase our steps similarly. Okay, and in this way we will move to left and right, as you can see. Now what we have the this is the final function, right? Longest zigzag, and we have given the root node. So we are taking root, and it's, you can say, 1/4. We go to the left or not, and we will go to right or not, and which one is called the max path, that we will return here finally. Okay, so this is the DFS review method. You have to consider this one, right? So if you have any doubt here, please ping me in the comment box. Okay, so I will help you there. Okay, now coming back to the complexity thing, right? So it will take time complexity is O of n, right? Because we have total number of node is n, and it is using DFS function, right? So we know that for all its every node, right, we have to traverse what? Of n times, because total n nodes we have, and we iterate over each edge, you can see, and it will take to complete all the nodes to it's all the n-1 edges, and the space complexity will take also of n, and this is the recursive call for, right? Thank you for watching this video. Thank you guys.